You know, there was something about this moment when these two scientists walk out of the forest onto Lake Rafenberg, and they were really speaking passionately about their work. I wonder what inspired them.
I think it was that walk in the woods. It was nature that inspired them.
And what is it about nature that can inspire us? Okay, so a bird. What about a bird?
Well, look at that bird. It's got wings. We can see that. But we have to take a closer look at what we don't see. And what we don't see is that its bones are hollow. Because its bones are hollow,
They're light enough so it can take off.
exactly.
Alright, what about an orange?
Well, an orange, what we see is that it has a peel and it's got fruit. And if we hold it in our hands, we can tell that this peel is tough. But what we don't see is that if we look at it under a microscope, that this peel is made out of millions of little spirals that can stretch and grow as this thing expands and gets bigger.
Okay, so what we're saying is that we really need to take a closer look and understand how things are put together in order to understand how they perform. Okay, so that's the natural model. But if we look at our site, what we really need to think about is the PIK, its needs, and its surroundings. And the architectural system on the smaller scale has to perform architecturally, whether it's light, whether it's structure, whether it's space. But more importantly, I think, the question of sustainability, that's what they are challenging us with. For me, sustainability is taking an intelligent system, and not only intelligent, but also applying it intelligently and efficiently, just like nature does.
Okay, so what does it look like? What is it made out of? And what can it do?
So that's when we take a closer look. But when you look at it with your eyes, you look at the natural model, it has a large organization logic, right? So how do we deal with that? I think that's a more intuitive, intellectual process. It's information given to us. It's us understanding what does a scientific community need, spatially, organizationally, and also programmatically.
Okay, let's look at topology. Let's start with something simple like a torus. It has an inside and an outside that we can start to identify, and we can preserve this moment even as we start to bend and stretch and twist this thing. But there's probably a point where it gets exhausting, and we have to add complexity simply by cutting and stitching these moments together.
So it's basically about organization.
Yeah, animals are organized a particular way, and our animal here is science.
Yeah, but this science, the PIK building, has 4 separate domains.
Sure, but how do those domains work?
Well, I think it starts in a highly specialized and controlled environment. That's where an idea gets generated, but it thrives in a highly open, dynamic surrounding.
So movement is important then?
Yes, for that purpose, definitely.
How great would it be if nature found its way into this equation?
So there's the forest, but what about the buildings? I mean, there's some landmark active research facilities around us.
Yeah, the buildings, the people, the trees, the dirt, they're all part of one larger continuous fabric.
Oh, and our building is going to be part of that fabric.
Yeah, and what does that look like?